Stanford physicists have a serious theory that says you are not human. You are a brain, floating in cosmic void. That popped into existence 30 seconds ago. With false memories of having read this sentence before, this is not science fiction. This is not philosophy. This is a calculation from peer-reviewed papers from Stanford, Caltech, Cambridge, and in some of our best models of the universe, the math says this is the most likely thing that could be experiencing this moment. By the end of this video, you are going to understand why. You are going to meet the man who accidentally invented this nightmare. You are going to see how it killed itself and how it came back. And you are going to feel something strange. The moment physics reaches up and grabs metaphysics by the throat. We call it the Boltzmann Brain. To meet the brain, we first have to meet the man. His name is Ludwig Eduard Boltzmann, born in Vienna, February 1844. Born on the night between Mardi Gras and Ash Wednesday, between Carnival and Lent. He liked to joke that this was the cause of his violent mood swings. Modern historians think he had undiagnosed bipolar disorder. Picture Vienna in 1872. Gas lamps, horse-drawn cabs on the Ringstrasse, coffee houses thick with cigar smoke and arguments about whether atoms even exist. Yes, whether atoms exist. Most respectable European physicists in 1890 would tell you with a straight face that atoms were not real. You cannot see them. You cannot measure one. Therefore, they are not science. They are philosophy. Boltzmann disagrees. Loudly, brilliantly. Alone. In 1872, he publishes the H-theorem. It is one of the most beautiful results in 19th century physics. He shows that if you assume the universe is made of trillions of tiny particles bouncing around at random, then entropy, the measure of disorder, must always increase. That is the second law of thermodynamics. The arrow of time, born from the chaos of invisible atoms. It is a stunning achievement, and it is instantly attacked. In 1876, his friend Joseph Lachmitt asks a deadly question. If the laws of motion run the same forwards and backwards, then how can entropy point only one way? You cannot derive a one-way street from a two-way road. The math will not allow it. Then in 1896, a young mathematician named Ernst Zermelo, armed with Henri Poincaré's recurrence theorem, drops the killing blow. Any closed system, given enough time, must eventually return to its starting state. Entropy cannot just go up forever. It has to come back down. Boltzmann is cornered. He fights back in journal after journal. He moves between universities. Graz, Munich. Vienna, Leipzig. Vienna, again. Every position comes with new enemies. His eyesight is failing. His wife, Henrietta, reads the journals aloud to him at night because he cannot see the print anymore. He is 60 years old. He is fighting for the existence of atoms, and he is losing. So, in 1895, in a short paper in the journal Nature, Boltzmann does something desperate. He invents an entire cosmology to save himself. Here's the move that changes everything. Boltzmann tells his critics, "Fine, you are right. In an eternal universe, entropy cannot keep rising forever. So picture this instead. Picture the universe as already dead, as already at maximum entropy. A vast bath of warm, featureless chaos that stretches forever in every direction. Heat death. Nothing happens. Nothing happen. Nothing happen. Almost nothing. Because statistics are stubborn. Even in heat death, by pure chance, atoms can briefly arrange themselves into a low entropy pattern, a fluctuation, a bubble of order born from nothing, lasting for an instant before dissolving back into the soup. Most of these bubbles are tiny, a few atoms, barely noticeable. But sometimes, over a long enough time, and eternity is very long, a bubble is large, star-sized, galaxy-sized, universe-sized, and inside that bubble, life can briefly evolve. Look around. Build telescopes. Wonder why entropy is so low? This, says Boltzmann, is us. We are not the universe. We are an accident inside the universe. A statistical hiccup. A bubble of order in an ocean of heat death. It is the first anthropic argument in the history of physics. Decades before anyone uses the word anthropic. And in a quiet footnote, Boltzmann credits the idea to his assistant, a man named Dr. Ignaz Schütz. Nobody is entirely sure whose idea it really was, but the seed is planted, and nobody notices what it grows into. Because, here is the thing about random fluctuations, if a giant bubble containing an entire universe is rare, then a smaller bubble containing only a galaxy is more common. A bubble containing only a solar system is even more common. A bubble containing only a planet, more common still. And a bubble containing only one functioning brain, with false memories of an entire life. That bubble is overwhelmingly the most common kind. Boltzmann did not see this. He died 10 years later in a hotel room overlooking the sea. The implication slept inside his footnote for almost a century. September 5, 1906. A small hotel on the cliffs of Duino, near Trieste in northern Italy. Below the window, the Adriatic glitters. The smell of salt and pine drifts up from the rocks. Far down on the beach, women in long bathing dresses are walking into the surf. Among them, a 14-year-old girl named Else, laughing with her mother. Inside the hotel room, the curtains move in the warm wind. Ludwig Boltzmann is 62 years old. He is on a family vacation. He has been fighting all his life for the existence of atoms. He has lost his eldest son, Ludwig Hugo, to appendicitis. He is going blind. He believes in this moment that the scientific establishment has rejected his life's work. He ties a short rope to a window frame, and while his daughter laughs in the sea below, he ends his own life. He leaves no note. When Else comes back from the beach, she is the one who finds him. 2 years later, in 1908, a French physicist named Jean Perrin runs an experiment on Brownian motion. He shows, beyond any doubt, that atoms exist. The theory Boltzmann died defending is vindicated within months of his suicide. His tombstone is in the Zentralfriedhof in Vienna. Above his bust, the marble is carved with a single line, S equals K log W. Entropy equals a constant times the logarithm of the number of ways the universe can be arranged. The deepest sentence in 19th century physics. The formula that lets stars burn. The formula that lets memories form. The formula that, taken seriously, says you might not be real. He never even wrote it in that exact form. Max Planck did. In 1900, Boltzmann lived another 6 years and saw it become the bedrock of statistical mechanics. The footnote slept. 1931. Cambridge, England. A famous astrophysicist named Arthur Eddington steps up to a podium. Eddington is the man who proved Einstein right during the 19 eclipse. He is the most famous British scientist alive. He gives a lecture called The End of the World from the Standpoint of Mathematical Physics. He publishes it in Nature, and inside it he becomes the first person in history to look at Boltzmann's fluctuation idea, follow it to its logical end, and recoil. Eddington asks a quiet, devastating question. If we are a rare fluctuation, then how rare are we? Because a fluctuation big enough to make a whole universe, With 13.8 billion years of evolution and 100 billion galaxies, that is a very large fluctuation. Astronomically improbable, but a fluctuation big enough to make just one human. With all of their memories, that is much, much smaller, far more probable, and a fluctuation that makes just one brain, floating in the void, equipped with the memory of a whole life that never happened. That is the smallest of all, the most probable of all. By the logic of Boltzmann's own idea, Eddington realized almost every self-aware observer in an eternal universe should not be a person. They should be a freak brain, hallucinating a person. He calls the result, in proper English understatement, absurd, but he quietly concedes the math works. And then he puts the paper down. The world has bigger problems. 1931, the Great Depression, the rise of fascism. Quantum mechanics is exploding. Nobody has time for a freak brain in a hotel room of equations. The idea sleeps for another 71 years. Fast forward to 1998. Two teams of astronomers, Saul Perlmutter on one side, Brian Schmidt on the other, discover something that breaks cosmology. The expansion of the universe is not slowing down. It is speeding up. There is a mysterious energy filling empty space. They call it dark energy. The math calls it the cosmological constant. It is the engine that will drive our universe over infinite time into a colder, emptier, lonelier state of perfect equilibrium. In other words, our universe is heading toward heat death, the exact heat death Boltzmann predicted in his footnote. And in that heat death, by Boltzmann's own logic, fluctuations should happen forever. In August of 2002, 3 physicists at Stanford noticed this. Their names are Lisa Dyson, Matthew Klebelin, and Leonard Susskind. Susskind is the father of string theory's landscape. Lay out the math, he says. Do not flinch. They post a paper to the Arcas with a deliberately ominous title. Disturbing Implications of a Cosmological Constant. The paper is a calmly written nightmare. They show that if our universe is really driven by dark energy, then over an infinite future, the random fluctuations in empty space will eventually produce a Boltzmann brain. Then another. Then another. They show with cold equations that the number of these freak brains is infinite. The number of ordinary observers like us in any one finite patch of space-time is not. You do the ratio. Almost every self-aware mind that will ever exist in this kind of universe is a fluctuation, a brain, a ghost. 2 years later, in May of 2004, 2 more physicists, Andreas Albrecht and Lorenzo Sorbo at UC Davis, write a follow-up paper. They need a name for this thing, so they coin one, the Boltzmann Brain. It enters the physics vocabulary 98 years after Boltzmann's death, born from a footnote he tossed off to escape his critics. How long until a single Boltzmann brain pops out of pure vacuum? About 10 to the power of 10 to the power of 50 years. To write that number out, you would need a 1 followed by 10 to the 50 zeros. There are only about 10 to the 80 atoms in the entire observable universe. You would run out of atoms to use as zeros, with most of the numbers still to write. That is how rare a Boltzmann brain is. And in an eternal de Sitter universe, the math says it still happens infinitely more. So, how do you kill the Boltzmann brain? For more than a decade, physicists tried. Some invoked vacuum decay. Maybe our universe ends before it can spit out enough freak brains. Some invoked exotic measure cutoffs in the multiverse. Some just shrugged and changed the subject. Then in 2017, A Caltech physicist named Sean Carroll wrote a short paper called Why Boltzmann Brains Are Bad, and he found a way to kill them that did not require any new physics. It required only honest thinking. Carroll's argument goes like this. Suppose you believe a theory of physics. Call it Theory T. And suppose Theory T predicts that in our universe, almost every observer is a Boltzmann brain. If that is true, then your own brain is almost certainly a Boltzmann brain, with false memories, including your memory of doing the calculation that produced Theory T. In other words, if Theory T is true, you cannot trust the chain of reasoning that led you to believe Theory T. The theory eats itself. In Carroll's words, the theories that predict Boltzmann brains are cognitively unstable. They cannot simultaneously be true and justifiably believed. It is one of the most elegant moves in modern philosophy of science. You do not have to prove the Boltzmann brain wrong. You just have to point out that any theory predicting it has already canceled itself. But here is the part that keeps cosmologists awake at night. Last year, in 2025, 3 researchers, David Wolpert at the Santa Fe Institute, Carlo Rovelli at Aix-Marseille University, and Jordan Scharnhorst, published a long paper in the journal Entropy. They went back to the absolute foundations, the H-theorem itself. Memory itself, and they found something quietly devastating. The standard argument that your memories reflect real past events, they showed, rests on circular reasoning. Physical law alone, they conclude, does not tell us whether to trust memories. We bring that assumption to physics. We do not derive it from physics. In other words, Carroll's escape works, but only because we already believe our memories are real. We can refuse to believe a theory that contradicts our memories, but we cannot prove our memories. You and I, sitting here right now, are choosing to trust ourselves. We always have been. We just never had to notice. Look at the brain again. The one in the void. The one you were maybe afraid of 3 minutes into this video. Notice how strange the question feels now. Are you it? Could you be it? The honest answer from 2026 Cosmology is, we do not know. There is no experiment we can run to find out. Boltzmann's footnote opened a door that physics still has not figured out how to close. But here is the wonder. The Boltzmann brain is not a horror story. It is the first time in human history that statistical mechanics reached up and grabbed metaphysics by the throat. It is the moment our equations got deep enough to question the equation maker. It is also the reason cosmologists still work, every day, on something called the measure problem. How do you count observers in an infinite multiverse? The Boltzmann brain is the canary in that coal mine. Any theory that lets the canary die has to be redesigned. Quietly, almost invisibly, freak brains are shaping the way humans think about reality at the deepest level. And maybe that is the strange gift Ludwig Boltzmann left us. Not a paradox to fear, but a mirror. A mirror that shows us the limits of what we can know, and how far we are willing to go to keep looking. He died in a hotel room above the Adriatic, certain that science had rejected him. He never knew that his quiet footnote, the one nobody noticed, would be the deepest thing he ever wrote. He never knew that more than 100 years later, a physicist at Caltech would stand in front of a chalkboard, look at the brain in the void, and use it to defend the reality of his own memories, to defend the reality of you. Take a breath. Feel the chair beneath you, the light in the room, the sound of your own pulse. Notice that whatever you are choosing right now to trust this moment. That choice is older than physics, and physics is finally catching up to it. The universe is stranger than we imagined, and the strangeness, it turns out, is the most honest thing about it. And maybe this is what real wonder looks like. Not certainty, but the courage to look anyway. Because somewhere right now, 400 kilometers above this planet, an astronaut is looking down through a window the size of a dinner table. She sees blue oceans, thin atmosphere, no borders. Her breathing changes. Her eyes fill. She does not know why. When she comes home, she will spend the rest of her life trying to explain what she felt up there. Psychologists have given the feeling a name. They call it the overview effect. It titles suggestions. 5 options. 1. Boltzmann Brain. The universe might be one. Hallucination. 2. Are you a brain floating in the void? Stanford says maybe. 3. The footnote that broke cosmology. Boltzmann Brain explained. 4. The most disturbing equation in physics. Boltzmann's Brain 5. He died in 1906. His idea says you might not be real.